Hello, my name is Alex, and in this video we're going to be delving into the basics of RxJS. RxJS is short for Reactive Extensions for JavaScript. It is essentially a library for reactive programming, which allows you to process asynchronous data streams from the backend with relative ease. Now, RxJS itself is a part of a larger library called ReactiveX, which is available for multiple programming languages. So let's imagine a scenario in which your backend server is sending you a stream of asynchronous data and you, as the front-end developer, need to be able to react to said data. In that case, you should be able to react to said data and trigger any corresponding callbacks. Now, RxJS gives you the tools to subscribe to said data streams and react to the corresponding data. This is why RxJS is considered to work on the reactive programming paradigm, since essentially it allows you to react to any changes in your data streams and act accordingly. Now, at its very core, RxJS is based on observables. Observables act like blueprints, and they essentially allow you to create a stream of data. When you define an observable, you're basically outlining how the data will be pushed to your subscribers, but the actual data stream doesn't start until the subscriber is essentially subscribed to your data stream. So essentially you can think of observables like objects to which you can subscribe, just like a magazine subscription. Once you're subscribed to an observable, you will be receiving the data corresponding to that data stream. Now obviously you can cancel your subscription at any time or wait for the event stream to finish on its own. Now, beyond subscribing to observables, you can also add operators to them. So basically, an operator is like a function which takes your observable as an input, processes the data, and then outputs a new observable. So you can imagine operators like intermediate layers between the received data and your eventual subscription. Before the data reaches your eventual subscriber, it is passing through those layers, and it is being modified and filtered through those layers before eventually reaching your eventual subscriber. So having that said, let's go ahead and let's look at live examples of working with RxJS, where we're gonna demonstrate everything we just mentioned in detail. Now let's begin with our Angular project here. Now if you're not familiar with Angular, don't worry, this is not gonna be in the scope of this video. Just know that we are using Angular to illustrate how you would work with RxJS in a real-life environment. So in this case, we have our application component here, which is going to be the first component initialized with our application. So in here, we have our constructor, where we're importing several services which we're going to be using. And then in here, we have the ng on init function, which is going to be triggered when the component is initialized. So if you're not familiar with web applications, you can think of this as window on load in vanilla JavaScript. Although it executes at a different time, the purpose is basically the same. So basically, this is triggered when this component is initialized. So having that said, let's go ahead and let's take a look at the actual page here. And in here, we're going to be displaying the output of our asynchronous stream subscriptions within this window. Now, having that said, let's go back and let's take a look at the HTML page itself. So in here, we have a very simple HTML document. And as you can see here, we have an output class, and within that, we have a message wrapper, and then we're using an ng4 to display every single output in our outputs array. So basically, going back to our component, we have an array of outputs, and when we've eventually subscribed to a data stream, every single output from that data stream is going to be added to this array. And then we're going to be using this array to display these outputs on our homepage. And in here, we're going to be breaking down every single output into its time and message properties. Now, if we go back to the component, you will see that we define a type here, and we specify that the outputs array is an array of objects which comprise of a time and the message property. So we essentially know that every single output will be of this format. So now, with that knowledge in hand, let's jump into RxJS and we will explain everything else when the time comes. And again, we're going to be using the ngOnInit function to run the code within this function when the component initializes. So let's go below ngOnInit and let's define our first function. So we will start with a function to create an observable. So the first thing you want to do is make sure that you import Observable from the RxJS library. Now, if you're using Angular, you don't need to install the RxJS library as it is pre-installed with Angular. Now, having that said, let's go ahead and let's break down what's happening here. So let's begin with the create observable function. Now, we will begin by creating a new observable from scratch. And essentially, to create an observable, make sure that you import the observable class from the RxJS library. Now, once you do that, you will be able to make your own observable. So basically, we want to create our own observable first so that we can subscribe to it later. So basically, we're demonstrating how you can make an observable from scratch. So we want to start by defining a new observable here. And as a parameter, you want to pass the following method. So basically, we are taking a subscriber as input, and then we are pushing the following events to that subscriber. So first, it's going to push 1, then it's going to push 2, and then it's going to push 3. So basically, we're simply pushing these integers to our subscriber, and then we're saying subscriber.complete to complete this series of events. So basically here we're using next to push a new event, and then we're saying .complete to essentially send a valueless notification of time complete from the observable. This, as it says here, notifies the observer that the observable has finished sending push-based notifications. So basically here we have a very simple observable which will send the numbers 1, 2, and 3 to the subscriber or observer, and then it will essentially complete. So let's create a subscriber which can actually consume this observable. So first things first, we want to define an observer. And now there are two ways of defining an observer like this. So this is the standard way to define an observer object. And in here, you're essentially opening a set of curly brackets, and then here you will have three methods: the next method, the error method, and the complete method. Now the next method will trigger every single time there is a value. So this will trigger on 1, 2, and then 3, and then error here will only trigger if there is an issue. Now complete here will trigger when this entire sequence completes, but only if there has not been an error. So if there is an error, complete will not trigger, but if next finished properly, then complete will trigger as well. So now we want to subscribe to the observable by using the observer, and in this case we're saying observable.subscribe, and then we're using the observer object right here. So basically, let's see how this works. So we want to call this method within ngOnInit. So let's go ahead and let's say this .create observable, and let's save that, and let's go ahead and let's actually see the output. So let's go into our website, and for now we will only see the output inside of our logs. And as you can see here, our output has been 1, 2, 3, and then complete. So far so good, but let's go ahead and let's try to throw an error. So basically, all we have to do is say subscriber.error and then the content of the error. And now we can go back here, and as you can see, the error was triggered. So we've successfully caught the error, and at this point, we stopped at 2 because the error was triggered before we sent number 3. And as you can see, complete did not return anything because there had been an error. So basically now we know how to subscribe to an observable, and we know how to build our own observer. Now usually this is not the format that you're gonna see, and usually you would define your observer directly in here. So basically, instead of creating a separate object, you would define it directly inside of your subscription here. However, you may want to create a separate object if you want to reuse it in the future. So having that said, let's go ahead and let's take a look at a deprecated way of doing pretty much the same thing. So back in the day, you would see this format floating around, where instead of stating an explicit object here inside of your subscription, you would use these handlers, these inline handlers, to handle your values, your errors, and your complete. So basically, instead of saying next, error, and complete, you use these three handlers. So this is a format which you may see in some older code, but it works in the exact same way. So if we go back here, as you can see, the exact thing has happened. We've displayed 1, 2, and then our error. But as you can see here, this method has been deprecated, so moving forward, make sure to use this format when defining your observers. So basically now we looked at a very simple observable, but now let's go ahead and let's try to create something that will output data during set intervals. So in this case again, we have a new observable here, and this time we have a counter. So this counter works based on the set interval function, and our subscriber is going to output an incremented counter every 1 second. So basically, this is a very simple observable which will essentially create a counter for us. Now here we also have a cleanup function which will trigger once we unsubscribe from this observable. So if we go down here we have our subscription, and we're defining our subscription here, and then we're saying observable.subscribe, and we pretty much follow the previous format. So now we can save this, and now let's go back into our browser, and as you can see, it is outputting these events endlessly. So basically, we're seeing an endless stream, and at no point will the stream stop because we have not defined any conditions for the stream to stop. So let's go ahead and let's actually fix that. So let's go down here and let's add an unsubscribe function after 5 seconds. So basically here we have a timeout which will trigger after 5000 milliseconds or 5 seconds, and it will call subscription.unsubscribe, which in turn will unsubscribe from this observable, and once we unsubscribe from this observable, this will essentially trigger the built-in clear interval function to cancel the timeout object. So let's actually save that, and let's go back here, and as you can see, we're counting up to 5, and as you can see, nothing happens. So basically, after we've outputted 5 results here, we've successfully unsubscribed from the observable. So now let's try to do something a little bit different. So instead of unsubscribing here, we're gonna throw an error after 5000 milliseconds. So let's remove this function from here. Let's go into our observable here, and below our interval, we want to actually throw an error after 5000 milliseconds. So again, let's save that and let's go back and let's see what happens. So as you can see, there has been an error, and although we're not unsubscribing manually, since there has been a problem, RxJS has handled it for us. We've received an error and the subscription ended. And if we go back into our code, obviously complete did not trigger since we've received an error, but let's say we want to trigger a function when everything is completed regardless of whether we receive an error or the subscription completes. So in both of these cases, we want to trigger something. Now, one way of doing that would be to essentially trigger the same function in both of those scenarios. So let's go ahead and let's define that function first. So the function is going to be named triggerMe, and it's going to just say triggered. So let's take this function and let's try to call this function from within our error, and we're going to do the same thing in here. So we're just going to trigger this function on complete, and we're going to save. So now let's go back. And obviously we expect this function to be triggered, and as you can see, this function was triggered because it was placed within the error. And this is as expected, but we want to avoid redundancy. So in this case, we're doing the same thing twice, but we can pretty much avoid this. Now, as I mentioned before, we can use something known as operators. So we can take the output of our observable, we can process that output, and then we can create a new observable from it. On top of that, we can react to this output or filter this output in various ways. So let's go ahead and let's do that. And in here, we have our subscribe, and we want to move this to a new line. So here, we want to remove this dot, and we're going to say dot subscribe down here. And up here, we can just say dot and then pipe. So a pipe is essentially a method which will allow us to add a series of operators to our observable. So inside of the pipe, we can then say finalize, which is essentially an operator which will trigger when the subscription ends. And then inside of here, we can just do this dot trigger me, like we did before, and we can save that, and let's go back in here. And as you can see, we get the same output. So basically, again, a pipe here is a method which allows us to add a sequence of operators to our observable. So basically, we're saying that after this observable is executed, once we receive new data, we want to trigger the pipes first, and then the result of that pipe will generate a new observable and pass it to our subscription. So now let's go ahead and let's take a look at the most commonly used operators. So first of all, I don't want to throw an error at this point, so I'm just gonna comment out the timeout. And now let's go back down here and let's begin looking at some operators. So the first one is going to be the filter operator. So in here we're stating that the value that we receive from the observable, so basically each single number, is going to pass through our filter here, and if that number modulo 2 equals 0, then it's going to be passed to our observer, otherwise it's not going to be passed. So basically, let's save that and let's go back to our page here, and as you can see, we're getting 0, 2, 4, 6, etc. So the odd numbers are not passed to our observer, and our filter function works as expected. Now the next function is take, and in this case let's just say take 3, and basically this function limits how many values can be returned from the observable, and then that observable will complete. So let's save that and let's go back here, and as you can see we get 0, 1, 2, and then the observable completes. Next up we have the map function, which is a simple mapping. So we're taking the value here and we're returning that value multiplied by 2. So let's save that and let's go back into our browser. As you can see, every single value is being multiplied by 2. Now next up we have the catch error operator, and in this case what we're doing is pretty simple. We're catching any errors, and then we're saying that for the error in question, we want to use the off operator, which is another operator from RxJS, which is going to create an observable from whatever we pass inside. So in this case, it's going to take that error and it is going to create an observable from this error. And then that observable is going to be passed to our observer. Now, in case you're confused, this is the same as doing this. So actually, let's go ahead and remove that. So in this case, again, we're essentially returning the observable with the error inside, but we want to avoid this redundant syntax, and we can just say off and then error, which is going to achieve the same thing. So without using the curly brackets, we can just return this observable here. So let's go ahead and let's add the error back, and let's actually save that, and let's go back into our application. And as you can see, we get our error that something went wrong, and then the observable completes. So basically we caught the error, but at the same time the observable has completed successfully because the error was essentially caught in here by our operator, and then we passed the error as a new observable. So in this case, this did not trigger the error method in here. So again, if we remove this pipeline and if we save, we can go back, and as you can see, this will essentially trigger the error. So in this case, we got the error message because we did not process the error in any way, so this essentially triggered the error. So now let's go ahead and let's get rid of all of that pretty much. So we're gonna clear our create observable function here. So now let's demonstrate a few other operators as well. So let's begin with off, and in this case, let's pass a few numbers in here and let's subscribe to that. So let's go ahead and let's subscribe. And in this case, we're using a simpler syntax, and we're gonna save that. And if we go back in here, as you can see, this immediately emitted 1, 2, and 3. And now we can go back. And now let's imagine that instead of passing these plain integers here, let's imagine that we want to pass an array of integers. So let's save that. And as you can see, this outputted the array as is. But let's imagine that we want RxJS to deconstruct this array for us. In that case, we can use from instead of off. And if we save that, as you can see again, we get the individual values. So basically, from can be used to convert various other objects and data types into observables. So now let's move on by exploring a few more operators. So first of all, we will explore MergeMap, but to do that, we're gonna need to set up an additional function here. So let's say we have a function which simulates a backend call. Now we're communicating with a server, you don't know how long you need to wait before a reply is returned. So in this case, we're saying timer, and then we're waiting a random amount of time here by doing math.random, and then we're basically returning the user ID here. So this is a bit overly complicated without a reason, but the point here is that we're returning a user ID after having waited for a random amount of time. Now down here, we're using off, just like we did before, to create observables from each one of these values. So basically here, we want to output the user ID 1, user ID 2, user ID 3, user ID 4, and user ID 5. Now MergeMap allows you to essentially get these observables concurrently. So you will essentially get these observables at the same time. So you won't wait for 1 to finish before moving on to 2. Instead, you will simultaneously basically get the values of these observables. So basically here we're saying pipe, and we're applying a MergeMap, and we're passing in the user ID, which we know is a string here. So basically we're passing on these values, and then we're calling this function. So again, this function is going to take the user ID and it's going to wait for a random amount of time. And then we're simply subscribing here and outputting the data. So let's save that and let's go back into our browser. And as you can see, we got the user IDs in random order. So we get 2, then 1, then 4, then 5, then 3. And in fact, if I reload the page, you'll see that again, we're getting those in random order. So basically, every time I reload the page, we're gonna get those in random order, but they are going to be executed at the same time. And basically, because the timer is random, the order changes as well. So now, if I go back here, and if we set the timer to simply 1000 milliseconds or 1 second, if I move back here, as you can see, no matter how many times I reload, after exactly 1 second, I'm gonna get these at the same time in the correct order. So basically, this is how MergeMap works. Now, if I change this to concat_map will actually wait for the previous observable to complete before moving on to the next observable. So let's restore math.random here, and again, let's import concat_map here, and now we can save, and now we can move back here, and as you can see, although the waiting time is random, every single observable here is returned after the previous observable has been completed. So next up we have SwitchMap, and SwitchMap is incredibly interesting in the way it works because it cancels every previous observable. So let's go back in here, and as you can see, the only output that we're getting is 5. So no matter the delay and no matter the configuration, it will essentially cancel every single observable, and it will only output data for the last observable. This is especially useful when you want to ensure that you're not subscribed to multiple observables at the same time. For example, if clicking a button results into a new subscription, you may want to use SwitchMap to cancel out older subscriptions. So basically again, SwitchMap will only subscribe to the latest observable and it will cancel out all previous subscriptions. Now next up we have ExhaustMap, and ExhaustMap is pretty interesting because it will essentially wait for the previous observable to be executed before it can execute any other observables. So if we actually save that and go back here, as you can see this outputs 1, and no matter how many times we reload the page, this will always output 1. So now let's simulate an ExhaustMap which works. So basically, for an interval of 1000 milliseconds, so basically every second, we want to take values from 0 to 4. So we can just say take 5. So basically, this will output values from 0 to 4. And then we want to say dot pipe. And then we want to use the exhaust map here. And then for every single value that comes in here, we want to emulate a processing task. So basically, we're emulating that our task takes 500 milliseconds. So again, we're using an interval. And in this case, we're saying take 1 because we want the observable to complete after the first input here. And then we're saying map, and then we're simply returning the value. So basically, the idea is that every second, we're basically outputting a value, and then we're passing that value to our exhaust map, which will emulate a task which takes 500 milliseconds. And then we're using console log on our subscribe, just like that, to console log the output. So the idea here is that every single value should successfully appear because exhaust map will only take 500 milliseconds to process this task. So if we save that and if we go back, let's actually reload the page, and you will see that we get every single value from 0 to 4, and basically our task completes. Now, if we go back into our code, we can actually increase the time here to 1000 milliseconds for the inner task, and you will see something different. So in this case, we get 0, then 2, then 4, and then the task completes. So the idea here again is that exhaust map needs to complete the assigned task before it can move on to the next observable. Otherwise, the next observable will be pretty much ignored. The last operator I want to mention is the tap operator. Now, the tap operator is incredibly simple. It returns an observable that is identical to the source, so it doesn't perform any manipulation, but it can perform a side effect on that observable. For example, if you want to log something related to the observable, you can do that using tap. So basically in here we're doing a tap and then we're doing a map. So we can save that and we can move back here, and let's actually reload. As you can see, we are getting the original values when we're tapping. And with that said, let's move on to a few real-life examples. So let's go ahead and clean up this function. We will remove the trigger me function as well for now, and we will save. And now I want to show you the API service in question. So the API service, you can imagine this just like a controller, which communicates with the backend. Now in here I have two endpoints. One is going to be used for a simple NodeJS server, and the other one is going to be used for a WebSocket server. So basically these are my two endpoints, and here I have three methods. So the first one is a simple GET request, which uses the base URL plus some kind of path to basically make a simple GET request to my Node.js backend. The next one is used to create an event source observable, and the idea here is that when the backend transmits some data in the form of events, we want to be able to create our own observable which should be able to handle this data. We're gonna return to this section later on, but just know that this method is used to create an observable which can handle a stream of data. And next up, the last method here is used to create a WebSocket, and then similarly to the previous method, it creates an observable which can handle a WebSocket connection. Now, having that said, let's move back to our component, and before we do anything else, let's quickly look at our Node.js server. So first of all, we're gonna look at the Node.js server, and we're gonna leave the WebSocket server for last. And the Node.js server is very simple. We have two endpoints, which are both GET endpoints, the first one being the JSON response endpoint, and the second one being the events endpoint. The JSON response endpoint simply sends a JSON as a response with a message and the time. So basically, this is not a stream, this is a plain GET response. Next up, we have our events endpoint here, and this creates a server-sent events response. So this is also known as SSE, and basically this creates a stream of events. So the only thing you care about is that for every 1000 milliseconds, we're gonna send a message to the front end with the time and the message. So basically, every 1 second, we're sending a message or an event to the front end. Now, for this to be recognized as SSE, we need to set the content type header to text/event stream. And we're pretty much done with the server, so let's close the server file. Let's go into our folder here and let's run the server. So having opened a command line tool, you can simply do node and then server.js, and you can press enter, and that will start the server. So basically now we can go back here, and in here we want to handle these two endpoints. So now let's go into our API service here, and inside of our API service, as we saw before, we have our plain get method and we have our create event source observable method. So the plain method here will essentially call the HTTP client, which is built into Angular, which will perform a GET request on our endpoint. So basically, by default, the HTTP client will return an observable to which we can subscribe. So automatically, we are getting an observable from our endpoint. So for now, let's focus on this method and let's go back to our application component. And in here, let's try to actually create the observable in question by using our endpoint. So basically, this is what we need to do. We're calling the API service to call the get method, and we're passing in our endpoint. Then we're subscribing here, and this handling here is exactly what we did before. We have our next, error, and complete methods here. And in here, we're pushing the output to our outputs array. So we're resetting our outputs array up here, and then for every single response we get from this endpoint, we're pushing the output to the outputs array. And since the output is in this format, where we have the time and the message property, we don't really need to manipulate it any further. So we can save this, and we can go back here, and as you can see, here is our output. So everything works well, and the observable has completed. But now let's go back into the server and let's try to emulate an error. So now back in our server, we are sending a status of 500 indicating an error with the following JSON. So now we can save that, we can go back into our terminal and we can restart the server. And now we can actually go back into our website and we can refresh. And as you can see, here is our error. So basically in this case, we get an error and then here we're handling the error in question. Now in here, if we expand this, as you can see, we get this error here. So theoretically, we could fetch this error message. So if we go back here, instead of just saying error, we can say error.error.message, and we can save that. And as you can see, now we're getting the error message itself. So basically, this is how you would handle errors, and obviously we can add a pipe here. So let's go ahead and let's actually try to add the catch error pipe in this case. So let's go ahead and let's just say catch error like this, and this will basically catch our error for us. And now we can actually save this and we can go back in here. And as you can see, in this case, we are successfully completing our observable, although we've received the error, and we're also outputting the error message. Let's actually comment out this line to make it less confusing. And as you can see, the only error we get here right now is the error due to the 500 response, but the observable itself has completed successfully even though we've received the error. So having that said, let's go back here and let's remove the pipe in question. And now let's take a look at the event stream. So let's go up here and let's go and take a look at the create event source observable. Now this method will create an observable, and the observable will return a message event. So basically we're saying that we want to create a new observable, and in here we're creating an event source, which is the default way of handling server-side events. And again, in here we're passing the endpoint and the URL, and then in here when we receive a message, so on message we're saying observer.next, and basically we're forwarding the message to the observer. On error, we're saying observer.error, and we're forwarding the error to the observer, and we're also saying event source.close. And then on cleanup, so basically when we unsubscribe from the observable, we're also saying event source.close. So as you can probably recall from the beginning of this video, we can build our own observables using things like observer.next and observer.error, and in this case we're doing exactly that to basically handle the event source in question. Furthermore, since we're on this topic, we're doing the exact same thing for our WebSocket, as we will see later. So basically these two methods are almost identical, but in this case we're creating an event source, while in this case we're creating a WebSocket. So having that said, let's go ahead and let's test our events endpoint. So in this case, let's actually go ahead and let's change this to create event source observable. And in here, we want to say events. And then in here, the data that we're receiving is a message event, so we know that. So basically, we cannot just simply push this data into this array since it expects a specific object here. So basically here, we're expecting this specific format, which does not match a message event. So what we can do here is simple. So here we can say JSON.parse, and then we can say data.data. So we know that the message event will actually return an object with a data object inside, so with a data property. And we can extract that by saying data.data. And if this is easier to understand, we can change data and we can just say E for event. So basically in this case, we would say event.data, and then we would parse that as a JSON. And because on the server side here, if we go down here, as you can see, this is the format of our event. As you can see here, this pretty much matches the format that we've declared up here, so a simple JSON parse will do the trick. So now if we save that and if we go into our Angular application and reload, you will see that we are receiving our events, but nothing is being logged. This is because Angular is not automatically detecting any changes. So basically we need to use the change detection reference here, or CDR, to force Angular to detect changes. So we can just say this .cdr.detect changes, and we can save that. As you can see now, our events are being successfully logged. So essentially this is how we can listen to events. And now let's go ahead and let's try to establish a connection with our WebSocket. So similarly, we need to start our WebSocket server, but before we do that, let's take a look at the server itself. So here inside the server file, again, things are very straightforward. We're creating a WebSocket server on a different port, And in this case, we will be broadcasting messages to all connected clients. So in here, we have a set interval function, and every 1000 milliseconds, we're using the broadcast function to broadcast the message with the time and the message, just like before, to all of our subscribers. So let's go ahead and let's start the server in question. Actually, we don't need to kill the server because it runs on a different port, but for the sake of using the same terminal, let's actually do that. And let's just say vs server, and that will start the server. And now we can go back into our service here. So again, in here, we're going to be using the create WebSocket observable function. And just like before, it works in the same way like the previous function, which handled our event source connection. And now we can go into our app component. And in here, we can just simply change this so we don't need to pass anything in here. And we can switch this for the create WebSocket observable. And actually, we can just save this as is. So let's save and let's go back in here. And as you can see, this works in a similar way. So hopefully this illustrates how you can subscribe to a stream of data from the backend using RxJS. So that's about it for this video. So I hope you've learned something new. This is a new channel, so every single comment, like, and subscription counts. And with that said, thanks for watching, and I'll see you in the next one.